Hello everyone and welcome to today's class. Today we're going to be talking about a very important topic in electrical installation. Today we'll be looking at electric circuits, understanding electric circuits, what it is, how it works and how it functions. Whether you are a beginner or you are a student or you just wish to know how electric circuits function, this is the best class for you. At the end of this class, you'll be able to design a simple electric circuit from beginning to finishing. You'll be able to troubleshoot any kind of faults that you discover in electric circuits. So follow us closely. This class is going to be in series. This is the first series. Pay keen attention. Turn on your notification button so that when next we post a video like this, do not mix any of it and have the complete video to refer when designing a circuit. Thank you and see you in our next video. So like we said, today we are going to be looking at a very important topic in electrical installation. Today we are looking at understanding electric circuits. Electric circuit is one of the very basic foundation in electrical installation. Without a basic knowledge in electric circuits, you will not be able to design any electric devices or to carry out any electrical installation. What is electric circuit, you may be asked, because you need to understand what electric circuit is. Electric circuit can be defined as any component or part that allow the easy flow of electric current. So that is basically an electric circuit. Then what is electricity? Before you talk about electric circuit, you need to also understand what electricity is. Electricity can simply be defined as the movement of charges called electron through a conductor, which can neither be a wire or any other form of conductor. But in electrical installation, we make use of wires or cables as the major conductive material for electrical installation. So that is electricity. So moving forward, there are three major components that make up a complete circuit. Without these three components, there will not be a complete circuit. Your circuit will be incomplete and unfunctional. It will never function. The first one is your power source. Your power source, there must be a source of power for your circuits to be functional. That is one of the major components of electric circuits. The second one is your conducting part. There must be a source of conductivity for the electric circuit to be functional, which is normally electric wires. Then the third one will be your load or device. The load you intend to power in that circuit, in that sector, that is your load. These three components is very important and must be present for a circuit to be complete. The first one is your power source. The second one is your conducting part. Then the third one is your load or device. When you have these three things in place, you have a complete circuit. Now, moving forward, let's look at the classification of electric circuits. Electric circuits can be classified in three main categories. There are three main classifications of electric circuits. Number one is types of current. You may classify electric circuits based on the type of current, and we have two major types of electric current. Number one is AC current. AC current. Your AC current can be defined as a type of current that does not move in a straight path. It does not move in a straight path. It moves, it's the type of current that changes path. It moves front and back. It does not have a particular direction. That is your AC current. And the AC current, you can get AC current from your grid. Number one is your grid. The type of current you get from the grid is known as AC current. Then number two source of AC current can be from your generator or generating set. Mostly in Africa, we make use of generator to generate AC current. Then number three is from your inverter, of course. Number three is from your inverter. Inverter is another source of AC current which converts your DC current to your AC current and be able to supply to your homes for the usage of your appliances. So your inverter is another source of AC current. And the full meaning of AC current is alternating current. Alternating current. It alternates, it changes direction. Alternating current. That is the full name of AC current. Now we talk about the second source of the second type of current, which is your DC current. Your DC current is the type of current that moves in a straight path. It does not change direction. It moves forward. It moves in a straight path, unlike AC current that changing paths. In your AC current, the number of times that it changes paths per second is known as frequency. It's known as frequency, and this frequency is measured in hertz. So when you look at your devices, you will see some of them written there 220 volts, 50 hertz. 50 hertz is the measurement in Nigeria electronics. I think in the US they use 60 hertz. So that number of times that your AC current changes direction per second is known as frequency, which is measured in hertz. Now back to DC current. DC current is a type of current that moves in a straight path. It does not change direction. And a good source of DC current is your battery. Number one is battery. Battery. And of course your solar panels. These are the two main sources of DC current. There are other sources of DC current, but for this class, let's make use of batteries and panel. I will be relating to inverter more often because this class is basically for AC and DC current, which inverter is a good example. That is why we'll be making more use of inverter in this class. So do not understand the two types of current we have, the alternating current and your DC current. If you notice, the DC current does not have a frequency. That is why it's not rated in hertz. So it cannot move front and back. It only moves in one direction. That is the major difference between AC current and DC current. We now look at another classification of electric circuit, which is based on connection. You can classify electric circuits based on the type of connection that you use in the setup. Based on the type of connection that you use in the setup. We have two major types of connection. Number one is series connection. Then number two is parallel. You can classify electric circuits based on these two major types of connection, and most times we make use of the third type of connection, which is series plus parallel. Some setup may require you to make use of the both in combination. So we have three types of connection: series connection, parallel connection, and series plus parallel connection. What is a series connection? This is very important to understand. What is a series connection? Series connection is a type of connection that adds up or divide your voltage while the current remain constant. That is a series connection. Especially in inverter installation, when you are using a series connection, your voltage tends to add up while your current remains the same. Let's look at that in a practical example. So like we said, series connection tends to add up your voltage while your current remains the same. For example, most inverters are rated to function at 48 volts, and some of the batteries or inverter batteries are rated in 12 volts capacity, which is not up to 48 volts, and you need to install a 48 volts inverter system. When you have 48 volts inverter system to install, you need to make up for this capacity. So you need 48 volts battery bank. Your battery is rated at 12 volts. So how do you make up for 48 volt system? You will be needing 4 batteries for your setup. 4 batteries for your setup. Let's say these are your batteries: 12 volts, 12 volts, 12 volts. Because you need a 48 volts, your best connection will be in series connection, and this is plus minus plus minus plus minus plus minus, your positive and negative charge of the battery. For you to achieve this, you need to connect in series connection. How do you connect in series connection? You take the positive charge of this battery and add it to the negative charge of this one. You take this negative charge and add it to the positive of this one. You take this positive and add it to the negative of this one, leaving you with a negative charge for the connection. The same way with this, you now take this negative and add to this positive. You take this positive and add to this negative. You take this negative and add to this positive, leaving you with a positive charge and negative charge. What you are doing is that you are adding the voltage of this whole battery. You are adding up the total voltage of this battery to come up to make up your 48 volt system. When you will now do 12 plus 12 plus 12, 12 multiplied by 4, what you have is 48 volts, which is needed for your device to function properly. That is how you can make use of series connection when you are dealing with DC batteries, which is below the voltage that is required for your system to function. Series connection tends to add up your voltage. Now, like we said, that your series connection can either add up your voltage or divide the voltage. So let's look at that particular definition. Let's look at it practically on this board. Let's take, for example, Nigeria electricity voltage rating is 230 volts. 230 volts is our voltage rating, but most times the power grid does not supply up to this. Let's take practical example, maybe a 220 volts. If your grid is supplied in 220 volts and you want to connect your devices, which is the load, in series connection, that will not really give you what you want, because this voltage will be divided into the numbers of the device that you want to connect. Let's say, for example, you want to connect 3 bulbs in series, 1, 2, 3, and these bulbs are rated to work to come up at least between 160 volts. These bulbs are rated to come up at 160 volts, and you have a 220 volts. You cannot connect. Your best connection will be in parallel connection. Why? Because of Ohm's law. Remember Ohm's law, which states that voltage is equal to current multiplied by resistance. When you do this calculation, the voltage you will have here will not be enough to power on these bulbs that you have here. Let's apply this formula and see what we will get. What we will get now will be, if you are looking for the current, this I represents current, is the symbol of current. Arrow represents resistance, is the symbol of resistance. But the unit of current is known as amps. This is the unit of current, while the unit of resistance is known as ohms. Yeah, this is the unit of resistance. So you are looking for current. Current is now equals to voltage all over resistance. If you apply this formula, the voltage you have here now will no longer be enough to power on this device, because each electrical device is built with a resistance. Let's say, for example, this bulb have like 1 ohms as the resistance, and for you to get your current, you add up the total resistance and divide it by your voltage. If this bulb are made with 1 resistance, now you will now have to divide this voltage by the total number of bulbs you have here. That is 220 volts divided by 3. What do you have? What do you say? 73.3 is the total voltage, which is not up to 160 volts that is required to power on this bulb. So the resultant effect is either this bulb does not come up at all, or it flickers because the voltage is not enough. It will not be stable. You need a maximum of 160 volts and to power on this bulb. And now you are having, when you connect in series, this voltage will be divided into the number of devices, and what you have is 73.3 volts. So this bulb will never come up. That is why we say that in series connection, your voltage can either be added up or divided. So when you have independent source of power and those power sources are connected in series, the voltage will be added up. But when you have a separate source of power and your device is connected in series, the voltage will be divided by the number of the device which is being connected. So understand these two different connection and behavior of series connection. Now let's move forward to the second type of connection, which is parallel connection. Let's continue with the second example, which is parallel types of connection. We have discussed about series. Now we are in parallel connection. We'll use the former example that we used before, which is connecting inverter batteries. So we have the number 2 example, parallel connection. Remember, we are connecting a 48 volts inverter system. Now this is the second battery and we want to connect this in parallel connection, plus minus, and they are 12 volts battery, 12 volts. If you connect this in parallel, you take the positive to positive, leaving you a positive charge, of course. Then the second connection, negative to negative, leaving you with a negative charge. What you have done here is that you are now, remember our example is a 100 amps battery. Let's say this battery is rated in 100 amps. What you are now doing is that you are adding up the current while the voltage remains the same. What you have here is a 12 volts battery and 400 amps current, which is not enough to power on your system at 48 volts. It can never come up. This inverter at 48 volts, there is nothing you will do that will make it to come up. It can never come up because the voltage is not enough. That is why the only type of inverter that can work with this kind of connection is a 12 volts rated inverter. The 12 volts rated inverter is your best choice for this kind of connection. And for this capacity of connection, 12 volts inverter is not your best choice, because the battery bank that is connected in a 48 volt system that is connected with this same battery and a 12 volts inverter that is connected with this same battery This your 12 volts inverter will run down. The runtime of this battery will not be up to that of the 48 volt system because it draws more power from your setup. The inverter draws more power from your battery to function. It is working with more strength and more current. We'll go into more details in this when you are talking about solar energy. When we are talking about solar installation, we go in more details in this. You will understand more how a 48 volts inverter can last longer than a 12 volts inverter which is connected with the same battery bank. So we now understand the difference between series and parallel connection. This is also one of the reasons why your household electrical wiring is done in parallel and not in series, because in series connection, when one component is bad, the whole of the component coming after that will stop working. But it's not so in parallel connection because each component function independently. That is why series connection is not used in domestic wiring. Parallel is the most useful because it will be a very bad experience when one lighting point in your house is bad and the rest stop working because one lighting point is bad. It will not be very good. So parallel connection is used in domestic wiring. Your household electrical wiring is done in parallel so that independently all of your devices can function without the other. So let's move forward to series and parallel connection. Sometimes in inverter installation, you need to make up for the voltage of your device and the current that is also needed to give you a reasonable outcome, because depending on the size of your installation, especially when you want to install a solar panel, because of your charge controller to be properly connected and functional, you need to make use of series and parallel connection. This is also very deep, but for this class we'll just touch on it briefly and go into details when we talk about solar installation. Right now we have to move forward to the third classification. Electric circuits can be classified based on condition. We have three conditions that can be classified with electric circuits. Number one is open circuit. Number two will be a closed circuit. Then number three will now be a short circuit. What is an open circuit? An open circuit is a circuit that is incomplete. The circuit setup is incomplete, so it will never be functional. Let's say, for example, this is your power source and this is a circuit. This will be your bulb. This is a circuit setup, positive and negative. This is your power source, and here is your circuit setup. When you connect the positive and the negative together to the bulb, this bulb will glow. When you connect the positive and the negative to the bulb, this is a closed circuit, the only complete circuit in this theory type of condition. This will be the only complete circuit. A closed circuit is the only complete circuit that you have in this theory type of condition, because the whole part is complete. This bulb will definitely glow. But when the connection is broken, let's say you have a switch here that break this connection, this bulb will not glow. This will be an open circuit. This will be an open circuit and the bulb will not glow because the whole part that make up a circuit is incomplete. The conductive part is not complete. The conductive part, which is wire or cable, is not complete, so the bulb will not glow. This is an incomplete circuit. Then what is a short circuit? A short circuit is a circuit that have leakages. your uh, your current, the current in that particular circuit is leaking from somewhere. The circuit is complete, but the current is leaking, is not functional, and this is very dangerous in electric circuit because number one, it causes electric shock. It can number two, it can also cause electric fire. Number three, it is very dangerous. It can damage your appliances. Open circuit can short circuit can damage your appliances. Because this should be avoided at all costs. There are so many causes of short circuit. The number one cause of short circuit that is very challenging in electrical installation is undersized cables. When you use undersized cables, it can cause a short circuit. We talk more on this when we are dealing with cable sizing, how to size your cables effectively in electrical installation. When we talk about your cable sizing, we'll talk more on the effect of undersized cables in electrical installation, which increases a short circuit. So this is the number three classification of electric circuits based on condition. Go through the class and put down your question. Leave us your question on the comment section, and also let us know any topic you want us to talk about. I will include them in our schedules of topic that needs to be attended to. But for now, this is the major foundation in electrical installation, understanding your electric circuit. This class is broad, so then follow us closely while you walk you through this very beginning of electrical installation. When we are done with this class, you'll be able to design a simple circuit, understand your electrical protective devices, understand how to size your cables and how to distribute your load effectively in the distribution box, and how to put all of this together to come up with a good and perfect installation. Thank you, and see you in our next class.